This is part 2 of the 2048 series. If you didn't watch part 1, go watch that now and then come back here to finish the game. Let's get into it. Okay, so last time I helped you create this grid here, which spawns our blocks onto the nodes. So now we need to actually shift our blocks depending on the player input. So we have just finished our spawn block state, and we need to go to our waiting input state. So let's change state, waiting input, and then let's hook into our update function. So basically, if it's not waiting input, we don't want to do anything. So we'll say if state does not equal waiting input, let's return. Don't do anything. But if it is, let's say if input get key down, and let's say the left arrow. Now we need a function here to shift all the blocks. So let's create a new function, void shift. And this will send in a direction like that. So then we'll say here shift, and this will be left, as that's the key that we're pressing. So now let's actually think about this, because this is where it gets a little bit confusing. So let's make it, let me get a good example here. Come on, come on. Okay, perfect. So we're shifting left here. So if we were to calculate this block first, we would say, all right, is there a space available next to me? Yes. Okay, is there another space available next to me here? No, because there's this 4 block here. So this one would actually shift to here. Then we would go to calculate this one, which would shift to here. But that's not what we want. What we would actually want is them both to shift across. So this one would go to here, and then this 2 would now shift across and take this spot here. So we, depending on the way that we're shifting, we need to order our blocks so that they calculate in the correct order. So how do we do that? Okay, so if we were shifting left here, we know that we need to calculate from left to right. So we would order our X to go from 0 up, and also in the same way, if we were going to shift down, we would also want to order our Y to be from 0 upwards, because we would want to do from bottom to top, wouldn't we? So let's just do that instance first. So let's say ordered blocks equals blocks.order by. Now first we're going to order it by the block's X position, okay, because we want to go from 0 upwards. And it would be very handy if, in the same way that we've got this helper function here on the node, we've also got it on the block. So now we can just say, let's order it by the block's X position. And we also want to do the same thing, but with the Y. So we'll say block, So first we want to order by, then we want to do then by. So first we'll organize by the X, then we'll organize by the Y. So B, and then the B position Y. So now this ordered blocks list has blocks ascending their X and Y. But what if it's the other way? What if we're shifting not to the left, but we're shifting to the right? Or what if we're shifting not down, but we're shifting up? So if we're shifting up or right, we need to change our behavior. So if direction equals right, or direction equals up, let's actually full on order reverse our list. So this will be to list, and this will be ordered blocks reverse. Okay, so now our ordered blocks list with just those 2 lines will already be in the correct order for us to calculate all of our blocks. Hope that makes sense. Okay, now this is really getting into the meat and potatoes of it. Okay, now that we've got our ordered blocks, we will loop through them. Block, and we will... So I was thinking about how to do this actually in the shower last night, how to best to do it. So I'm going to do it in a do while loop. And the reason I'm using a do while loop instead of a while loop is because I always need to do this at least once for every block. So the difference between do while is it will always execute once, and then basically we'll just act like a normal while loop. So basically what we're going to do is we are going to start with our current position. So var, and I'm going to call it next, and this will all make sense in a moment. And I'm going to call this block, and I'm going to take its node, which I haven't put on yet. So this block, just like the node holds the occupied block, the block itself is also going to hold a reference to the node that it's on. So node. And we actually also need a function here so that when we actually set down our block, it sets its node. So set block, and this will take, whoops, it will be a void set block. This will take in a node. So I'm going to say, first, if we're moving this block and I'm already on a node, I need to release my current node's hold, don't I? So I'm going to say, but we may not actually have a node because it might be the first time we're actually setting the block down, so no node is set. So we have to actually if check this. If node does not equal null, we'll say node, and we'll take its occupied block and we'll say null, because it used to be me, now it's not because I've moved. We'll set our node equal to the new node that we've just sent in, and we'll also say the node's occupied block now, this new block that I've just occupied, I'm going to say I am now the new block that is part of that occupied block. So set block. So now, before we continue here, when we're spawning these blocks here, we're initializing them, but we also need to set the block to the node. Okay. All right, so now down here, as we've got our node reference now, so basically what I'm doing is I'm saying the first place that we're going to check is ourself. Okay, so that's always going to return true. There is a spot because we know we're already in it. So here, the first thing that we're going to do is we're going to say block, set block, and we're going to send in next. Okay, so we're already saying, all right, the next block that we need to check is our own. Okay, so immediately into this do loop, we're saying, yep, block set ourselves again. Okay, we're literally unsetting it and setting it. But now we need to do something. We need to set next to another block, the next one down the row, so that on the next iteration of the while loop, this next will actually be the next block in line, right? Okay, so what we need to do now is we need to find a possible node, and we need to take our current node, which is next. Okay, so that could be the node that the block was originally on, or it could be the next block next to it, depending on how many iterations of this while loop there's been. We need to get, so let's make a little function here actually. This will be node, get node at position. And this will just take in a vector2 pos. And now the beauty of using just a standard list as opposed to a 2D array here with an X and a Y is we don't need to do any special checks to see if it's out of bounds of the array. We can just say I'll return nodes first or default node position equals position that we just sent in. Like, as simple as that. If we were using a 2D array here, we'd have to say, is X less than 0? Is Y less than 0? Is X more than the width? Is Y more than the width? We would have to do all those checks before we can even ask the array, or else we'll throw an error, an out of bounds error. So that's the beauty of just using a list. Not as performant, but far easier to write and understand. So, possible node, get node at position, and we're going to be sending in our next dot position, okay, so the one that we're already on, plus direction, so our shift direction. Now, this could return null if it's out of bounds, so this might be like -1. So we need to check here, we need to say if possible node does not equal null. So now we know that a node is available. We know a node is available. Sorry, not available, is present. So now we just need to check, is that node available for us to actually place on? So we can say if possible node dot occupied block equals null. Awesome, that's what we want. Let's say next, our next block to check equals possible node. Do you see? So now let's just go through this. We're saying we're starting with our current node and we're just setting it immediately. But then afterwards we're saying, all right, is there another node next to me? If there is and it's available, let's set this next variable to this new block that I've just checked is available. Okay, so then in this while loop, we'll say, this will be the condition to see if we should go back up to the top and set this new block as our furthest block. So we'll say this condition will be if next does not equal our block dot node. Yes. So our next, as long as, yeah, so if next is different to our currently set node, then we know that we have actually set something here and that we can continue this loop. Does that make sense? And just for demonstration's sake, let's just change the transform direction right now, like as we're here. So we'll say block.transform.position equals, so we've here just discovered our furthest block that we actually can move to. We'll say block transform position, and we'll send it to now the block node dot position, because just remember, through this do loop, we are setting the new nodes each time. Each time we move, we're setting it. That doesn't mean that we're actually moving to it, okay? So we've got to manually do that here. So let's try this out. Let's go back to Unity. And if we press left here, perfect. So it moved to here, and then it reset the do loop, and then it moved to here, reset the do loop, and then it tried this one. It tried this, but it said, it returned no. Yes, there is a possible node here. But is it occupied? And yes, it is. So it did not set the next node. All right, which means this next is the same as the block's current node. So then it came down to here, is next different to this block's node? If it isn't, then we haven't found a new node to go to. So just exit the block and then move the block there. Okay, does that make sense? Let's just try it one more time. Perfect. Working just as expected. Now, just teleporting the block there isn't too fun, and it also doesn't give as much visual debug. Like if you can imagine, when there's all these blocks that are going to be on the screen and we're trying to work out all these bugs, you know, why is this happening? Why is this happening? Just pressing the buttons and then the block's just teleporting all over the place. It's not going to tell as much. It also doesn't look that good. So instead of showing you how to manually lerp objects, which is not actually how I would do it anyway, I'm going to show you a package which will do it for you. And to be honest, it's the best Unity package that has ever been released. In my opinion, I use it in every single project. So it's called .tween, and basically it will just handle all of your transform movements, okay? And you can add different ease types to it, and it's just super easy to use. So go there. This is free, by the way. Just grab it from the package manager. If it's not showing up here, go to the unit assets store, just click import into Unity and you'll have it. So I'm just going to import. When it imports, you'll get this little menu here. And the good thing about .tween is they know that you're not going to use every single component of it. So you can actually turn off everything here, which we don't need any of this, and apply, and it makes the binary, the compiled version far lighter on your end result. So now that that's done, if you just go to your scripting editor, reload, as a whole load of stuff has just been injected. Now, instead of us saying this here, right, we can say, now this is the magic. We'll say block.transform, and .tween has given us a whole load of functionality here. We can now say do move. Okay, do move, and we want to say the first parameter is the end value. Where do you want to move this? And we want to move it to the position of the node. And then we want to say, how long do you want this transition to take? Now, I want all my blocks, regardless of their travel distance, even if they're just moving 1 or if they're moving all the way 4, I want it all to take the exact amount of time. I'm sure it will give it a nice snappy feel. So serialized field, float, travel time. And I'm going to default this to something like 2. That might be a little bit too fast, but we'll see. So now I'm just going to send in that travel time, just like that. So now you'll see with just that one little line there, how much improvement this will make, like that. And while we're at it, let's duplicate this line here, and we'll add right, whoops, not right, alt, right, and then this will be up arrow, up, down arrow, down. So now we should be able to move all over the joint. Down. Beautiful. Look at that. Well, yeah, we can do that because we're not actually stopping player input. We'll get to that. Okay, so actually we can get to that right now. We can say, as soon as we've triggered this shift, we'll say change state moving. So now we won't be able to actually add additional input. Okay, now we need to worry about merging. So, okay, so now in here we're saying if the block is not occupied, cool, we can move to that location. But what if the block is occupied, but it is the correct block that we need? So let's change this. Let's say if possible node dot occupied block does not equal null, and possible node dot occupied block dot value is equal to our block value. If so, we need to say that this block can merge into this new block. So let's add a public variable here on our block, and this will be called block, and let's just call this merging block. So we're saying if this is set, we can check this, and then all other blocks can know this block is in the process of merging. Okay, we don't care what block this is. They just need to go, if it's not null, then we know this block is merging in this transition. So here we've said the block is the block on the next space is not null, and it's the same type as me. So what I'm going to do is I'm going to say block merging block equals the occupied block, and then we also want to make sure that if there's other blocks behind me, they know that they can now take my new spot. Also, I need to let the other blocks who might be behind me know that my spot is now available, even though that I'm not setting block. Okay, so a few things are going to have to happen here. So let's create a function on the block. Public void merge block, and this will take in a new block, and this will be the block to merge with. So then in here we can say our merging block equals the block to merge with, we want to allow other blocks to use our spot. So we will say node.occupied block equals null. To allow blocks to use it. I know that there should be something else here. Okay, so we're saying that yes, other nodes can go into our spot. We're saying that I'm merging already, so Nothing else is allowed to merge with me because I'm already merging. But what about the block that we're merging with? So the block that we're merging with also needs to be telling other blocks that they can't merge because they're already merging. So yeah, so picture this. Perfect. Picture this. So say there's a 2 here, a 2 here, and a 2 here, okay? And we push them all to the left. So then the first 2s will start merging, and we only want 2 blocks at a time to merge. We don't want all 3 blocks to merge. So these 2 will go into this block. This one will unlock its space and say, yep, I'm merging with this one. So then this one will come along and it will check this block and it will be like, nope, I can't merge into you. But then it's going to come over to this original block here, and there's nothing saying that this block can't merge because it's a 2. So I'm just going to merge into it. So we need a way to make the original block also say that they're merging. So this here is for the block that is merging, but we also need a variable here for the original block. So this will be merging. So then we can say block to merge with dot merging equals true, and that will protect both blocks. Set the base block as merging so it does not get used twice, or 3 times or 4 times, depending on how big your board is. So let's also make a little helper function. So public bool can merge, and this will take in a value and will return. First up is, so this function will be called by another block. So it's going to detect the block, it's going to send in its value. So we're going to say first, if value equals value, so these 2 values match, and we're not merging, and merging block equals null. So we need to check all of those things, and if all of those things return true, then we can say, yes, we can actually merge this block. So instead of doing this check here manually, we can just say, is the block, does it have an occupied block and it's not null? Yes. Okay, well, let's say possible node occupied block can merge, and we're going to send in our block value. So that will return, can our new block merge with this current block? If so, let's say block merge block, and we'll send in the possible block, the occupied block, and we only want to run one or the other. So let's say else if. I know this may sound a little bit convoluted, but it's a work in progress, we'll see. So here, we know the node is present. If it's possible to merge, set merge. Otherwise, can we move to this spot? And then if none of those hit, we're basically not doing anything. We're just saying, you know, if none of those hit, we're saying none hit, and do while loop, because we haven't found a new block to do anything with. So let's see if I haven't broken anything yet. And it looks like I have. That's because we're setting our chain state to moving, and then we're not actually continuing the game. So to do that, this is an asynchronous function, right? Like we're calling it, and then code can continue down here, but while that's happening, this is still moving to its destination over the travel time. So we need a way to wait for this. And to be honest, we don't really want to do it here anyway. So let's now that we have gone through our ordered blocks and we've set our new block positions, whether it's by setting it to the actual place or saying that we're merging, we can now go over this for each in ordered blocks. We're going over the list again, and we're going to say far Like where do we need to move now? So it's either going to be to our new node, or if we're merging as a block, it's going to be to the base block, isn't it? So move point equals, and we're going to check block, are we merging? If so, our move point will be the block dot merging block dot position. Otherwise, we're going to be moving to the block dot the node that we've set dot position. So now we have our endpoint. Now, a beautiful thing about dot tween here is we can queue up a whole load of different animations and then get a callback when it's finished. So look here, we can actually say on the end of this dot on complete, right? And then we can actually run a function once this completes. So we can run this logic when this block actually finishes transitioning. But we actually need to do this for a whole load of blocks, don't we? So we need to know that they're all finished. So we can do this. We can say var sequence equals dot tween dot sequence, and we can take this little move script here, and we can just say sequence dot insert, and we're going to be running these all at the same time. We don't want to sequentially run them. We want them all to run asynchronously. So we're going to say we're going to insert this at index 0. We're going to just chuck in that that tween that we just had up here, right? And now this sequence is holding all the blocks travel places, travel animations. So we don't want to hard code that. We want to actually move it to the move point. And now instead of directly saying on here on complete, we can now say sequence on complete. Please run this code once they've all finished their animation. We don't care about the ones that we're just moving to a new spot, but we do care about the ones that we're merging. We need to do something about that. So for each ordered blocks where block merging block does not equal null. Yes. So we're going to loop through all the ones that are merging into a new block. And to merge, we need to do a few things. So let's make a function, merge blocks. And we'll say block, base block, and then block, merging block. So the first thing we need to do here, and let's just call this merge blocks, block, and then block, merging block. Pretty easy. Now we already have a function called spawn blocks. So that's being called with a number, with an amount, and then we spawn all the blocks using that. But that's not really what we want. We want another function called spawn block. We just want an individual place to do this, and we want to send in a node and probably also a value. So if we just grab this code here, so then the node is being used, and then the value straight up, and we'll just cut that out and we'll say value. And now we can call this spawn block, send in our node, and then send in that value string again. So that's now using this. And now that we've got this function here, we can specifically spawn our new block. So spawn block, base block, it'll be on the base block node. And then the value will be the base block dot value times 2. Yes, so now we're spawning this new block. Then we need to destroy the 2 merging blocks. So let's make another function, remove block, and then we'll say, first we need to remove it from the list. So blocks.remove, and then we'll remove block. Yeah, finished it for me. And then we need to actually destroy the object. So let's destroy block game object. Cool, so now we need to just destroy these 2 blocks. So remove block, base block, and then remove block, merging block. Cool, so we're moving them. When they're finished, we're going to go through the ones that actually merged, and we're going to say merge block, which is going to spawn the new block of the new value and remove our previous blocks that just merged. Yes, cool. And we don't need to reset these two variables because these blocks are actually getting destroyed. So then once we merge those blocks, now let's say change states, spawn blocks, spawning blocks, and that will now go to spawn the blocks, but now the round is at least over 0, so now it's only going to spawn the 1 block. Then it's going to go to our waiting input. So let's see if that worked. It's going to be a miracle. So up, down, oh, object reference not, let's check what that is. Move point block dot merging. If block's merging, do that, otherwise, So this merging block is not the orchestrator. We need to say if block merging block does not equal null, then we'll use the merging block position. Otherwise, we'll use just the R position. Yes. Let's try that. Up, down. That merged, but that didn't look right. Yes, that is not right at all. Block merging block dot position. Aha. So here we're saying the move point is going to be the merging block position, but that's not correct. We need to set it to the new node of this merging block, because if you remember, we're setting the nodes, but we're not actually moving to them. And then we're just trying to say here, let's just set it to the current position of the merging block, which is incorrect. So we need to set it to the node, the new node of this block's position. Yes. So as a pointer, like when you're going through this, you should always set it to the position of the node and not the block, because the node may be out of sync with the block. Good rule of thumb, I suppose. Whoa. That is working pretty nicely. Don't see any bugs until right there. So what happened there? What happened? So we've got a 4 and an 8 there. What did that mean? What did that mean? Okay. So we're merging in the wrong place. So merge blocks, block, merging block, spawn block, base block, node. Okay, so I've made this function here, merge block, and saying that the first one is the base block, but then here I'm actually sending in the block as the base block, which is incorrect. It's the merging block, which is the base block. And then the block is the one merging into the merging block. Okay, let's try that. Was that right? Yes, I think it was right. Ooh, yes. Nice. I think that's working. I don't know if I'm good or bad at this game. I think I'm probably not very good. I'm sure you guys don't want to watch me play this the whole time. Plus I was probably about to lose because I'm trash. So we need a win condition, don't we? So we can actually, to make this dynamic, we can say serialized field private int win condition. And let's default this to 2048 as that is the name of the game. But you can change this to any duplicate of 2 below 2048 and we can actually make that the win condition. So you could possibly create a game where the first few levels is only like 32, you know? as a little practice. So where do we actually look for a win condition here? Probably in spawn blocks, right? So if we've spawned a block, here we can actually check lose. So instead of just putting this comment here, we can actually say change state lose, as we know that they have just spawned in a new block in the very last square, which makes moving impossible. And then down here in change states, we can now say blocks, is there any block with a value of the win condition? If there is, let's send in game state win. Otherwise, let's go back to waiting for player input. What are you doing? Oh, that is incorrect. So is there any blocks with the value of win condition win, otherwise waiting input? So obviously you have to set your win condition correctly. If you set it to a number that is not actually available, they'll never be able to win. So I don't know if this would be better as like an enum. You'd have an enum for each number, or what, but right now I've just got it as an int. Cool. So now here we can, let's make some 2 more references. Private game object win screen and the lose screen, and then in our win we'll say win screen set active true. Golly gosh, my typing. And then lose screen set active true. And then in the game, let's create a canvas, and this will just be text on a screen, and this will be the win screen. Oh my golly gosh. Win screen, and then lose screen. Let's make these both centered in the screen, and they're tiny. So then this win will be winner. This one will be loser. And then let's disable them by default. And then in Game Manager, slap in our win screen. Where are you? Win screen, lose screen. And let's set this win condition to 32, just to see if this works. If I can get to 32. Let's see. I think I'm pretty trash at this, to be honest. Oh, I'm close. I'm so close. 32. Winner. There you go. That's the game. That's I think I couldn't see any bugs. Not too much code. Not too clean, but could probably be refined quite a lot. But that's about it. So there it is. I hope you enjoyed the video. I know it was pretty lengthy. Leave a like if you stayed this far, and let me know in the comments what you thought. Tarodev out.